Hi everyone, myself Dr. Lakshmi Prasad, working as an associate professor in the Department of Data Science in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various definition and terminology in the concept of statistics for data science. So the very first question is that, so what are characteristics of statistics? So the statistics are nothing but the aggregates of facts, and these statistics are to be numerically expressed, and these statistics are going to be affected to a marked extent by multiplicity of the causes, and the reasons reasonably standards of accuracy in enumeration and estimation and collection, and these statistics are going to be collected in a systematic manner and is going to be collected for predefined purpose. So mainly the statistics are going to be used in many of the applications and for the estimation for collection, and mainly where you can able to be expressed and where you can able to perform some of the operations. So what are the various statistical methods? For that we are going to have descriptive statistics and scientific statistics. So should be comes under this applied statistics, and statistical methods also available for evaluating this various measures of statistics. So normally the applied statistics will be have two types like descriptive and then scientific. So what is sampling? Sampling is nothing but a process of selecting of observations where you can able to call it as a sample to provide an adequate description and inferences of the population. So sample is nothing but a unit that is going to be selected from population and represents the whole population as well. And the main purpose is to draw the inference, and the sampling frame is going to be listing the population from which the sample is going to be chosen. So sampling is the process of selecting the observations to provide an adequate description and inferences to the population, and the sample is nothing but a unit that is going to be selected from the population and represents the whole population, and the main purpose is to draw the inference, and sampling frame is the nothing but the list of population from which the sample is going to be chosen. And sampling actually this should be the various process of the sampling. Initially we're going to have population, so from this population we're going to be select one frame set of sample, what we call as sampling frame, and this entire process the extracting some part of this sampling frame what we can able to call it as the sampling process, and this sample can be treated as inference of this population. So basically what is the sample means, what we actually observe in the data is nothing but a sampling sample. Okay, so here this is the design of the sampling. So you are going to have a population from which we are going to be select some set of samples, and extracting that we can able to treat it as a sampling frame, and extracting of simple some set of data from this population what we can able to call it as a sampling process, and this sampling process should be treated as inference of the population. And so the sample is nothing but the actual observation in the data. So normally population will be two types like homogeneous population and heterogeneous population, where the group of different people will be there. In homogeneous only same kind of people will be available. So extracting a similar kind of people of the same thing of different categories is nothing but heterogeneous population. And describe about the sampling design process. So the sampling design process will be looks like this. So initially you have to define the population, and then we have to determine the sampling frame. So this is the population initially we are going to have, and in this we are going to be extract some part of this population and determine the sampling procedure. So what kind of procedure can able to apply? So again, this sampling will be of two types, like a probability sampling and non-probability sampling. Probability sampling will be looks like this. So simple random sampling, stratified sampling, cluster sampling, systematic sampling, and multi-stage sampling. Non-probability sampling means convenient, judgmental, quota, and then snowball sampling. So if I'm going to perform this probability sampling, so which kind of method is suitable for this application, I have to be choose it out. So whether it should be simple random or stratified or cluster systematic. And non-probability means convenient, judgmental, quota like this. And how to be determined the appropriate sampling size, and then we have to be execute the sampling design. So this should be the process of sampling design. So here we have to be initially define the population, and then we have to determine the sampling frame. So from this sampling frame we have to determine the sampling procedure, and we have to be determine the appropriate sampling size, and then we have to be execute the sampling design. So what is simple random sampling? So simple random sampling means all the subset of frames are going to be given an equal probability and then random number generated. So in this one, so we are going to have set of names of employees. In simple random sampling, we are going to extract some of the names of the persons, and that thing should be treated as simple random sampling. So all the subset of the frames should be of given an equal probability, and then the random numbers are going to be generated. In simple random sampling, we are going to take advantages and disadvantages. So for that, the minimum knowledge of population needed and easy to analyze the data. And disadvantage is that the low frequency of use does not use researcher expertise and the larger risk of random error. So here, the simple random sample is going to have main advantage is that so that much expertise is not required for implementing this simple random sample, and it should be also easy to analyze the data when compared to others. When it comes to disadvantages, so the low frequency of use should be the simple random sample and does not require the researcher's expertise, and then the larger risk of random error. So this is the disadvantage of this simple random sampling. Stratified random sampling. So here the population is divided into two or more groups, what one able to call as strata. So the population is divided into two or more groups, what we call as strata. The subsamples are randomly selected from each strata, and seeing the example, so we're going to have so many samples of data, and in these samples I want to segregate the people of different religion like Caucasians and then African Americans and Hispanic and Americans. Okay, so that should be treated as a stratified random sampling. So here the population is going to have different kind of samples. Africans, Americans, and Indians. So I want to segregate only the Africans. I want to segregate only Americans. I want to segregate only Indians. Let it be. So then that kind of sampling should be treated as stratified random sampling. The next question is that what is a stratified random sampling? So what the advantages of this stratified random sampling is that So it is going to be assures the representation of all groups in the same population. It is going to be assure the representation of all groups in the same population. And then the characteristic of each stratum can be estimated and comparisons can be made easily. So in stratified random sampling, we're going to be assured the representation of all groups in the same population, and the characteristics of each stratum can be estimated and comparisons can be made. And the disadvantage is that it should requires accurate information on the proportions of each stratum, and the stratified list costly to prepare. So the disadvantage is that it is going to be required the accurate information on the proportion of each stratum, and stratified list costly to prepare. And the stratified random sampling means that it is going to be assured the presentation of all groups in the same population, and the characteristics of each stratum can be estimated and comparisons can be made easily. And next one is that what is cluster sampling. So the cluster sampling means the population is going to be divided into subgroups like families. So here we're going to have so many houses, and this group of houses should becomes under one section of area, and this section of area going to contain these following houses, and this section of houses should becomes under section 4, and this section of houses contains section 5. What would like to say that is, so the cluster sampling means the grouping of houses having some similar characteristics. So this group of houses is going to have one similar characteristic, and this group of houses is going to have one similar characteristics, and this group of houses is going to have one characteristics, what we are able to call it as a clusters, and this set of those houses is going to have some set of characteristics. So like this we are going to be cluster the group of houses having the similar characteristics. So here the population is divided into subgroups like families, and simple random sample is going to be taken from the east cluster. So what are the advantages and disadvantages of this clustering? So by make use of this clustering, you can easily estimate the characteristics of both cluster and population. And disadvantage is that the cost is going to be high in order to reach the element to sample should be. And each stage in sampling, cluster sampling introduces sampling error, and more stages are going to be identified. Uh, so the cluster sampling is going to be estimate the characteristics of both cluster and population, and here the disadvantage is that it should be uh, where the cost is going to be effective one in order to make the designing of clusters, and each stage in cluster sample introduces the sampling error is going to occur, and since we are going to maintain so many stages. So what is systematic random sampling is the next question. So in systematic random sampling, all the units in the sampling frame we are having that, so in that sampling frame we have to be select the items or units in a systematic way. Suppose we are going to have a sampling interval of 10 people like this, and selecting this third sample multiples of third, so 3, 6, 9. So the systematically collecting all the samples with multiple of 3, so that thing should be treated as a systematic random sampling. So in systematic random sampling, suppose we are going to have another set of data like 11, 13, 9, 8, 2, 9, 6, 1, 12, 17, 18, 5. So this is the set of data we're having. So systematically selecting among this, so third one, otherwise I'm going to take another fourth one I'm going to consider. So fourth one, 1, 2, 3, fourth one, and next one is also same. If we are going to have 19, next. So like this we are going to be select all this samplings here in a systematic way. So what are the advantages of this sampling? So it should be moderate cost and moderate uses, and then simple to draw sample and easy to verify. And disadvantage is that the periodic ordering is going to be required. In systematic random sampling, so we're going to be have so many advantages. So the cost should be very low when compared to other samples, and moderate usage, and then you can also draw the sampling very easily, and then you can also verify very easily. So the only disadvantage is that the periodic ordering is going to be maintained here. And next one is, what is multi-stage sampling? So this multi-stage sampling is going to be occurred in different stages. So usually smaller and smaller units at each stage. Suppose if you are going to have a group of clusters like this, so again the cluster is further divided into two or more clusters, subclusters, what we can able to call. So if I'm going to take 2, so 3 more clusters are available. If I'm going to take 3, so 4 clusters. If I'm going to take 6, 3 more clusters, and some 5 more subclusters are available inside. So they should be treated as a multi-stage. So again this one is further divided into some more clusters, A, B, C, D. Again this subcluster is again further divided into another A, B, C, D. And again this one is going to be divided into A, B, C, D. So like this we are going to be divided. So what are the advantages and disadvantages of this sampling? So in advantages, we are going to take, it should be more accurate. It should be more accurate and effective one. And disadvantage is that it should be costly. And each stage in sampling introduces the sampling error. And more stages are there, and more errors are tends to be occur. So in multi-stage sampling, we have to be very careful. So in multi-stage sampling, the cost should be very effective one, and then the sampling errors is going to be occurred while distributing the samples in different stages. But the only advantage is that it should be more accurate and effective one. And next one, what are non-probability sampling? So these non-probability samples are nothing but where the probability of each case being selected from the total population is not known actually. So normally the units of the sample is going to be chosen on the basis of personal judgment or convenience, and there are no statistical techniques are available for measuring the random sampling error in a non-probability sample. So non-probability sample means the probability of occurring each case being selected from the total population is not known. That is the first thing. And the units of sample are going to be chosen based on the personal judgment, and no statistical techniques are going to be available for measuring this random sampling error. So in that we're going to have different types of non-probability sampling, like convenient sampling, quota sampling, judgmental sampling, snowball sampling, and self-election sampling. So in convenience, quota, judgmental, snowball, and then staff selection. So these are the different types of sampling. So the sampling is going to be convenient sampling. So the convenient sampling involves the choosing the respondent at the convenience of the researcher, and the main advantage is that it should be very low cost and then extensively used and understood one. So when it comes to disadvantages, so the variability and then bias cannot be measured and controlled, and projecting the data beyond the sample is not justified, and the restrictions of the generalization. So the advantage is that the variability and bias cannot be measured, and projecting the data beyond the sample is not justified, and then restriction of generalization. And next one is that the population is well segmented to mutually exclusive groups, just as stratified sampling. And the advantage is that it is going to be used when the research budget is limited and very extensively used and understood, and no need for the list of population elements. So the advantage is that it is going to be used when the research budget is limited only and very extensively used and understood, and no need for list of population elements. And disadvantage is that the variability and bias cannot be measured and controlled. It should be time consuming, and then projecting beyond projecting data beyond the sample is not. So the advantage is that when the research budget is limited and very extensively used, and no need for list of populations. And the main disadvantage is that the variability and bias cannot be measured. It should be time consuming, and projecting the data beyond the sample is not justified. Next one is judgmental sampling. So here the researcher employs his own expertise judgment. So the main advantage is that it should be an assurance of quality response and meet the specific objective. So here the main disadvantage is that the basic selection of sample may occur, bias selection of sampling may occur, and it should be a time consuming process. So in these disadvantages, the bias selection of sample may occur, and it should be a time consuming process. An advantage is that it should be an assurance of quality response meeting the specific objective. The researcher employs his own expertise judgment. And next one is that snowball sampling. So here the researcher starts with the key person and introduce the next one to become a chain. So what are the advantages of this? So it should be low cost, and then it should be useful in specific circumstances for locating rare population. And this disadvantage is that it should not be independent, and projecting data beyond the sample is not justified. So these are the disadvantages of the sampling. So it should not be independent one, and then the projecting data beyond the sample is not justified here. So the main advantage of the sampling is that it should be low cost and then useful in specific circumstances for locating rare populations. And next one is self-selection sampling. So it occurs when I'm going to allow each case, usually individuals, to identify their desired tasks or desire to take part in the research. So the main advantage, it should be more accurate and useful in less specific circumstances. And the disadvantage is that it should be more costly due to advertising, and the masses are going to be left. So self-selection samples should be more effective and then more accurate, and then it should be useful in many circumstances. And disadvantage is that it should be more costly due to advertisement and marks are going to be left. The next question is that what is sampling error? So the error is going to be arise so when I'm going to use the sampling surveys are known as the sampling error. So two types of sampling errors. The first one is biased, unbiased, and random sampling. So bias sampling means that so due to the selection of samples techniques or based on the size of the sample, we're going to be get biased errors. So due to the selection of sampling techniques or due to the selection of size of the sample, so normally the biased errors is going to be appear. When it comes to unbiased error or random sampling errors, so the members of the population is included or not included. So that is the difference here. So the differences between that the members of population is included or not included. So that is the difference between unbiased or random sampling. So some of the random non-sampling errors are going to be identified. So should be referred based on the bias, and the mistakes are going to be taken in selection of sample. So the causes for the non-sampling errors will be sampling proportions and inadequate of response and misunderstanding the concept, lack of knowledge and concealment of the truth and then loaded questions, pre-processing errors and then sampling size. So what are the various methods available for reduce the sampling errors? So for some of the specific selection methods and systematic documentation of related research, effective communication and an effective pre-testing, and it should be control the mechanical basis and selection of appropriate sampling techniques is also going to be selected. In this selection of appropriate sampling techniques, we are going to have so many techniques, and then we are going to be control the methodological bias as well. So describe about various measures of central tendency. So some of the measures of central tendency will be that mean, median, and mode. So here the data with one variable what we called as a univariant, and the measures of central tendency or the number that is going to be described in the middle of the data. So first one is that mean. So mean is nothing but adding up of numbers and divided by how many are there. And median means the middle number. So just going to put the numbers in numerical order and find the middle one. So if there is an even number average, then that should be equal to the two middle numbers. And so mode is nothing but it should be number that occurs more frequently is nothing but the median mode. Suppose if you are going to have the data like 10, 20, 30, 40, 50, 60 like this. So the mean is nothing but 10 sum of all the values divided by number of values. It should be the mean. Median means so middle of this. Mode means the number that occur more number of times. So let it be 50. 50 will be the answer. So what are the ways of finding the measures of central tendency? So this is the list of data. From this I'm going to find the mean. So first I have to adding up of all the values and divide by number of numbers. That should be the value of mean. And median is that we have to put all these numbers in ascending order and then selecting the middle of this number is 15. That should be the median. And mode is nothing but which is going to occur more number of times in this list, that is 10 and 10. So that 3 times it is going to occur, then this one should be the answer. So what are the various measures of central tendency? So the mean is nothing but when the data is spread out and you want to an average of all these values, and median is nothing but when the data contain the outliers and these outliers are going to be divided into. So once the data contains the outliers are the values that does not fit on the rest of the data. And mode is nothing but when the data is tightly clustered around one or two or more values. So the mean is nothing but, so the cluster we are going to have, so this is the data of the cluster. So the data which lies outside the cluster, so that and all should be treated as outliers. And the mode is nothing but the data which is going to be tightly clustered around one or two or more values. So what are the equations that are going to calculate the variance and standard deviation? So normally the numerical value is going to be associated with how the data is going to be spread, and the range is that, so largest value minus smallest value, that should be the range. And the variance is nothing but just going to measure the how much data value that is going to be different from the mean. So sigma is equal to x1 minus x1 whole square, and x2 minus x bar whole square, and x minus x bar whole square. So this is the standard deviation equation for finding out this. And next one, how are we going to find the variance and standard deviation? So what are the steps you have to perform that? So the variance, so find the mean difference between the mean data value and mean. So square mean differences and adding them up of and divide by number of data values. And the standard deviation is nothing but the square root of variance only, and I'm going to get the value of this. So for finding the standard deviation, you have to be uh, find the mean as well as you have to find the difference between the data value and mean value, and square the difference, adding them up, and have to be divided by number. So finding the measures of variance like 3, 5, 7, 9. So how are we going to find the range? So largest value minus smallest value. And how are we going to find the standard deviation? So first find the variance value. So for that I need the mean value, and then standard equation, and what should be the value 8, that should be standard deviation minus variance, and square root of 8 should be the standard deviation. The next one is that what is the hypothesis testing? So hypothesis testing make an assumption about the population parameter, so collecting the sample data and circulating a sample statistic. So using this sample statistic we are going to be estimate the hypothesis, and to test the validity of our assumption we are going to determine the difference between hypothesized parameter and sample value. So there are different types of hypotheses, like null hypothesis, which is going to be presented with H0, and alternate hypothesis, which is going to present HA. So next one is defines the confidence interval. So the parameter is a number that describes the population statistic, and statistic is the number that describes the characteristics of the sample data. So inferential statistics is going to be drawn the conclusion from the data, then I'm going to use the inferential statistics, and sample is nothing but describing the data, and then use sample statistics to inference the population parameter. So some of this will be estimation and then hypothesis testing, and this should be the various diagram of the confidence interval. So first we have to be collect the data, and then have to be apply the descriptive statistics. So from the descriptive statistics we are going to make graphs and measures like location and spread and statistical inference, and this one should be calculated by means of estimation and hypothesis testing, and finally have to make the decision making. So these are the various equations for finding the mean, and then variance, and then proportion. So define the point estimate. So the single number that is going to be calculated from the simple data is nothing but some point estimate, and which is going to be resulting that the number is going to estimate the true value of the corresponding population parameter. So normally this is going to be does not provide any kind of information about how the close the point estimate is that to the population parameter, and does not consider the sample size also, and the variability of the population from which the sample was taken. So sample size and the variability of the population are going to affect the accuracy of the estimation. So the point estimate is not really useful, and this one should be overcome by using interval estimates. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.